Welcome back. This will be part 2, basics with radicals, possibly common denominators, and definitely some approximating irrational terms. On part 1, we had looked at the square root of 1200, broke down the number under the square root into some perfect square factors times 3, rewrote the square root of 1200 into simplest form. I would call this an exact answer, 20 times square root of 3. And then we approximated the irrational number with a decimal or a rational number, positive 36.64. Okay. And as we continue with part 2, we're going to look at something similar to the blue problem. We're going to rewrite the opposite of the square root of 48. So this would be a negative value, and our answer in simplest form should also be negative. Okay. So each time I see a number under a radical, if I don't think it's in lowest terms, I just factor this number and I look for perfect square factors. So 4 times 12 might have started a factor tree. 48 can be thought as 4 times 12. And then a person would need to recognize that 12 can be broken down into another perfect square times 3. And I notice that those 3 factors at the bottom of the factor tree become 3 times 16. And that's just one way to write, but it's a helpful way of writing 48. 3 times 16. So now that I recognize, since this is the opposite of a square root, there's an understood coefficient of -1. So I get -1 times square root of 3 times square root of 16. Because if you have a product under the radical, then you would have the square root of each of those factors. The square root of 16 is positive 4. I can commute 4 to the left and multiply -1 times 4, and I get a coefficient of -4 times square root of 3. Now the square root of 3 is irrational, which makes the entire product irrational, and it cannot be written down as a terminating decimal. So if I approximate, I might use the calculator to approximate 3. I know it's going to be less than the square root of 4, and so I get a decimal that is less than 2. And another way to write that product, would be negative 6.92. Or if we read with place value, negative 6 and 92 hundredths. Okay. One more example on this video, and then we'll go to part 3. We want to be able to use these skills we've talked about to simplify products and quotients, but let's just look at this product. 7 times square root of 15 multiplied by 2 times square root of 27. Now if we simply took 7 times 2, we would have a factor of 14. And then, oh goodness, if we took 27 times 15 under the radical, you'd have to check me, but 27 times 3 is 81. 81 times 5 would be about 405, and the number under the radical would just get bigger. So I chose to rewrite 15 as 3 times 5. No perfect squares there, but the square root of 27 was 3 times 9. And I could have kept that under one radical. I don't know why I chose to split it up. But now I'm going to commute the 2 to multiply the 7, and I'm also going to take square root of 9, which is 3, and commute that with the 2 times 7. So working backwards, make sure I'm in the frame here. I've got 3 times 2 times 7. I've commuted and put 3 times 2 times 7 on the left, and these factors that remain under the radical, I've continued to write under the radical. Okay, so you might want to take inventory, but all the factors from step 2 I've written in step 3. And if you can jump from step 1 to 3, that's fine. We recognize that under the radical there's another perfect square. This is equivalent to 5 times 9. Square root of 9 is 3, and I moved that square root outside of the radical. The only number that had to stay under the radical was that factor of 5. I did a little cleaning up. The green factors on the outside became 126. 5 was left under the radical. And when I approximated here in red, I got something a little bit bigger than 2 times 126. So if I was estimating, 126 times 2 would have been 252. So this had to be bigger, and it is. And that would be rounding to the nearest hundredths. Okay, good luck with simplifying radical expressions.